start out by quickly identifying the technologies you want to use, lay out the project that you want to implement, and not just hand waving, but some fairly concrete details. Okay, milestones or something would be a good way to do it. Um, and they could change. Again, I want you to reach high, and if you don't quite take that last bar, that's okay, not a problem. But so you'll get up and quickly itemize the technologies you're going to use. Talk about the project, what you're trying to accomplish. What is it? What's the purpose? What are the steps I got to do to complete this project successfully? And then start talking about the technology. So you're giving us a tutorial on the technologies you're going to be using, Node or whatever. If there's time, I may do a mock tech presentation for you, just to give you my model of what it ought to be. But I'm not sure that there will be time. We'll have to see how long it takes us to get through the comm material and so on. So, but my mental model is that you'll probably take a half an hour for that first presentation. Wouldn't hurt if it's longer. We'll just, some days we'll do only 2 people instead of 3 if it's longer. Wouldn't want to be way longer and wouldn't want to be way shorter. If you talk for 10 minutes, you don't have a very well-formed idea. If all you have is 10 minutes worth of stuff to say. So, but half an hour is, you'll be surprised how quickly that goes. Oh, my time is up already? Okay. So, I think only one person owes me a presentation. There's a couple. Nooper she was still deciding what she wanted to do, and she gave me a sampler of all kinds of things she was thinking about doing. So, that needs to settle out fairly quickly. At any rate, that's the schedule for the technology presentations. I'm sure the way it's going to work is almost by the time we're done with the technical presentations, it'll be time to start with the probes, and that'll probably take us pretty close to the end of the semester. The final presentations traditionally have been 2 days, the weekend, Saturday and Sunday, the weekend after the last day of classes. So if anybody has a scheduling problem with that, let me know right away, because I think it almost has to be that way. You have a problem?
I definitely will. It's my season, growing. So I don't think I'm out of town, but I'll probably have practice. Some graduation stuff.
Okay. So let's make sure, we'll work around that. Let's just make sure. Probably won't be a problem getting a few of the presentation, 2 or 3 of the presentations in on the last day of classes. But there certainly won't be time to get all the final presentations done, for sure. So we'll do the we'll not now because I'll forget, but later on in the semester, make sure you remind me about that. We'll schedule around that. Okay, so please, if you haven't given me a write-up, do so right away. Now, I want to talk a little bit about Project One because it relates to the other things. I mainly want to talk about VS Code, using VS Code in Linux, and I handed out a file system handout that I think you'll need to use for your Project One. This is the Linux version, this is system version as well. So, let's start talking a little bit about Project One. So this is a text search component, as I hope you remember, and we're going to build two components. Now this is a text search facility, and we're going to build two components that implement that. Basically, a file manager component, which just does a recursive directory walk down some tree, delivering file names. And in order to do that directory walk, you need this file system setting. C++ doesn't have, as of C++ 11, doesn't have a directory interrogator. Okay, you can open a file, close the file. If you know the file, you know where it exists, you can do that in C++ just fine. But you need to use the platform APIs to explore the directory and stuff. And so I wrote that, did it here. There's a file system Windows and a file system Linux, and you have both. I know I have fixed a couple of bugs in the file system Windows that I don't think got fixed in file system Linux because I don't use the Linux as much, but I'll be looking at that over the next week or two. Probably my intent is to have made sure that that was all squared away by the end of the weekend. A component, again, is a piece of code that provides an interface, a class that implements the interface, and there may be other classes that the implementer needs. There's a class factory that creates everything and gets it going. And it needs to be implemented as a DLL. So the functionality you're going to provide is quite straightforward, not very horribly challenging, intentionally so, because I want you to focus on COM. You're going to wrap it in COM on Windows, and you're going to build your own something like COM, much smaller, much simpler, but something like COM on Linux. And so, you know, you'll have plenty to do without getting into some really heavy, you know, functionality. So the functionality is quite straightforward, I think. I would recommend that you just implement the requirements in C++. Forget the components, forget COM. But just try to have packages that, you know, divide this up so you have a file manager package and a text search package. Get that working, you know, and that's a weekend max. Probably a Saturday, okay, to do. All right. So, and it's fine, you know, these are text files, unless you do one of the optional things. These are text files, and so opening them and reading them are really simple. So you can do that, and then probably while we're talking about COM, you won't be ready to wrap it in COM. It takes us COM that's a kind of a, you know, you got to build up the speed, get up the speed first, you know. So you can be working on the Linux part while we're talking about COM. You can start taking your core, you know, your file manager and text searcher and wrap them in components for Linux, implement them on Linux. And to do that, it's just standard C++ stuff, the interface and an object factory, which you have examples. We've already been through some of the examples on the class account. You've seen that. So the only real thing for Linux is to figure out how dynamic linked libraries work in Linux. And I've got a couple of examples we may look at today. It's easier than it is on Windows, okay, because you don't have to decorate it with a decal sample spec, import and export. And then by the time you finish that, we'll be ready to, we should be done with COM, and you can implement it with COM. And what you'll discover is that it'll take you several days of monkeying around with it before we'll talk about COM in some real detail, and you'll kind of understand it, but it isn't until you really try to wrap up stuff in COM that you learn all those little details. So, and I think the due date is sometime in March. I want to make sure that we finish COM, and so you want to plan your activities. Initially, you got two things cooking. One is Project One, and the other is getting ready to do your tech presentation. And Project One is a small part of your grade. I think your primary focus, your goal ought to be succeed with Project One, but maybe you're not going to do all the fancy bells and whistles and stuff. Okay, keep it as minimal, so you can focus on the final project. Okay, so let's start. So, are there any questions about this before I've asked you to do a little bit of script stuff, but this can be really easy script stuff. All you have to do, you can do some interesting shell scripts and interesting PowerShell scripts. You can satisfy these requirements by doing nothing more than starting your project with a bash script in Linux and a PowerShell script. That's easy to do. Okay. So I would start looking at this. I would start working on the code part. And again, it's a Saturdays or a little more work. Okay. So let's take a look at VS Code. I am developing a love-hate relationship with VS Code. I like it. I do. I like it. But there's parts of it that annoy me a little bit. VS Code, in my opinion, is almost an ideal environment for Linux. It's simple, nice, fairly easy to use. There's a few things that I haven't quite psyched out yet, but mostly it's simple and easy to use. VS Code on Windows is more complicated. Behind VS Code, so there's a text editor, but as soon as you want to compile and debug code, there's, on Linux, a shell environment and some JSON code that's setting up properties. And that's very straightforward, very easy to do. On Windows, there's a PowerShell environment that made, all of a sudden, everything got harder. Okay. It's powerful, you can do lots of stuff with it, but the stuff, lots of stuff you gotta do. So my original intent was that I would probably do a significant amount of my development with VS Code on both Windows and Linux. And I still may. I'm not abandoning Visual Studio. I like Visual Studio. Visual Studio is great, but for fairly lightweight, small projects, just bang, up comes VS Code, really easy to get going. So, but if I use VS Code on Windows, I may well install GCC and MinGW or whatever it is, the library, the ported new library, and run those on Windows rather than, because the PowerShell stuff, I think if you took the time to learn it, it would be really useful. You could do some good stuff. But there's a bit of a learning curve. They got, and their documentation, there's no hello world documentation. It's, oh, look at this neat little feature. 10,000 little. Never saying that this is PowerShell. What's good? They're manipulating PowerShell and stuff, So, but anyway, system program problem detected. So I have got to restart this guy. I think it's probably just because I shut it down. I might have shut it down improperly. So what I'm going to do is I'm going to run VS Code, and we're going to compile and run the debugger on this file system. I'll make a few comments about the Linux version of it. My virtual, I may have some problems here. I ran out of memory in my Linux. I made a pretty big virtual machine. You know, we gave it a lot of disk and a lot of random access memory, but not quite enough. Okay. Partly because I was loading a whole bunch of stuff, and so I purged it. I uninstalled Eclipse. I uninstalled NetBeans. I uninstalled old versions of Ubuntu. You know, I cleaned up a whole lot of space, but I think I cut off a little bit too much. So I've been having a system problem detected. Doggone you. Come on. I ran you after. So let me just make sure that this is going to run, and then I'll talk about yeah. So now, just let me bear with me, and then I'll back up and I'll explain some of what's going on. Oops. So, okay, so everything's working, so let me back up and explain things a little bit. So, let's first take a look at what we got. So, let's look at the tasks. This is the funny Unity interface at work here. One of the things that kind of bugs me. They stole these menu items ought to be up here, but Unity steals them and puts it on its own window menu. Why they did that is beyond me, but they did. So if you ran this in Windows or probably in GNOME, you know, when they come out with a later version of Ubuntu with the GNOME interface, this guy will have the menu items on his own bar where they ought to be. But anyway, VS Code is an editor, a nice one, to compile stuff and build it. You have to generate a task, and a task is basically a set of it's defined by a set of JSON. Really, I'm sure MongoDB is running behind here. Okay, and so there's a lot of JSON stuff here that defines stuff. So in this tasks, So tasks, this is an array, okay? Task colon, an array of tasks, and I have two tasks I've defined. So one, this is just a label. When I run the task, you may or may not have noticed, when I ran the tasks, down came a drop-down menu, and what was on it, this is just puts items in that menu bar. But you know what the task is, tasking. So now, and I am going to use the shell to execute these. And my command is make. I'm using a very simple make files that handed out, and nothing fancy at all. And so my command is make. So what this is doing is this is invoking the GNU make facility. The way make works is if you have a single file named makefile, it just executes that. It does, you know, and we'll talk about what executing means in a minute. But if you have more than one makefile, then you can say make -f. I'm going to give you the name of the makefile, whatever. And you can name it anything you want. It doesn't have to be makefile. But I named it makefile file system and makefile file system test. And my file system test was, depends on a whole bunch of directory structure that is in here, it's going to fail, and that's okay. The make of the file system builds, runs, executes correctly, as far as I know, okay. But the file system test was, you know, a sequence of tests that I set up when I was building it that depended on a whole bunch of directory stuff, and I didn't put any of those directories in place, so it's going to fail. It's going to get really unhappy. Stuff it can't find. But anyway, so I am invoking make with these arguments, -f, and this is the name of my make file. Okay, this is for make file system test, and the group is the kindest build. Okay, so that'll come up when I if I pull a build task. Is default is true. Okay, and I probably has default is true on the other one. I should only have it on one. Here's the make file system. I do. So one of these should be false. But and so, but it also has the task has this problem matcher, and what that means is that if it fails, if whatever you're doing in that task fails, then this gives you the opportunity to report that. Probably with something you use to carry out that test. So I'm using GCC as my make is using GCC, and so I'm just using GCC's errors. So the problem matcher is just going to look at the GC output and show any problems that occur. And we won't see any in the first one, and the second one we will. So here, problem matcher, GCC, and I could probably say in the command $make, I didn't experiment around a whole lot, you know. I'm not sure I fully understand their language, you know, what their script language, but I'm not sure exactly how. And I have a task that just builds a single file. It doesn't use make, just to show you. So here's a label build. Using the shell, G++5 is the command, that's what I'm starting up, and then test underscore file system. So this is I am activating the main. I'm giving it the define so that it will compile the main, and I'm telling it I want C++11, and I'm going to use pthreads, although I don't need them here for this. It's just default. Generate debugging information, and then I'm giving it a very explicit path. But I think there is a workspace directory symbol that I can use. I haven't experimented with that at all. I'm pretty sure I don't really need to give it a full file path. And so these are the tasks that I define. And then here's a task, this launch task I think was already there in, came with VS Code, and this just launches the debugger. So we're using the GDB debugger, and here's workspace folder / a.out. So I think I could say the same thing in my, just workspace folder when I was referring to that file that I wanted to compile. No args. And then it has some properties, stop at entry, false, change working directory to the workspace folder so the tool operates correctly. Nothing, I'm not putting anything in the environment now, although I could here, and so on. External console. So what you'll see is instead of it appearing in the terminal here, there's going to be a separate console that pops out here that you can see, because this terminal is pretty small. And there's some setup commands. I didn't supply any of this. This all came with VS Code. Set commands, enable pre-printing, blah 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 blah. All of this is really quite straightforward. It makes sense. The Windows version is a bunch more complicated because it's written in PowerShell. I'm sure this is a shell script running behind all this, or a series of shell scripts, but they're running PowerShell scripts in Windows, and it's a little more complicated. So so now, when I say tasks, run task, down comes that drop-down menu, and there's the labels that I gave it, make file system test, and build. Those 3 tasks that I defined. So let's just, I'll run this in a minute. I want to look very briefly at the code before we do. And now, there is a file. So this launcher and my tasks are saved in a hidden directory called, on Linux, it's .VS Code, and inside are these 2 files, the JSON files for those launcher and I think when you create a workspace, it creates that directory and just loads those 2 files in it. I'm not sure. I haven't played with it enough to be exactly certain of what. There is a create whatever it was. Create workspace is what it was. So, anyway, so let's take a quick look at filesystem.h just to explain things a little bit, because you're going to need to use this on Linux. Make that pain go away. No, that didn't do it. Oops. Oh, I don't want all that. What I was trying to do is to get rid of the file map over here. Some way to do that. Managed to do it once. Put over there. But anyway, let's expand this out. And so here's filesystem.h. And so I'm going to skip over my comments and just take a little bit of a look at the code. There is a block class which I don't think you will use. I made the block class to enable reading a binary file and passing it to a stream, socket or something like that, take this block, take this block, take this block. There's a class file that supports, there's get put block and get block and put block, does this file exist? Copy it, remove. So that's the kind of things that the file class does. And there's a file info class that you can get things like the file's date, time, and look at its properties. Is it archived and compressed? And is this size, gets the size off the directory entries. Basically just pulling entries out of the directory structure. And there's some comparisons, and these are time comparisons. I probably, earlier, later, smaller. So these are size comparisons, smaller or larger. These are time comparisons, and these are time comparisons too. And there's a path class. Get full file spec, get path, get name, get extension. If you've done any .NET stuff, System IO, its path class is just like this. I stole its design. Its file info class is a lot like mine. I stole its design. There is a directory class that lets you create a directory, remove a directory, see if a directory exists, get the current and set the current, and get files and get directories. And here's what you need for the file manager. Get files, get files and get directories, okay, and then we'll do a recursive walk down the project tree using those. There isn't much giveaway here that this is a Linux package. This is a little bit of stuff if you look at it, but if you look at filesystem.cpp, now all of a sudden, there's a whole bunch of includes, there's the standard C++ includes, but now there's a whole bunch of includes like dirent, systype, syscall, sysstat, sysenv. Those are all Linux. So we're not going to walk through all the gory details, but the operations in a header file are what you need to implement the file manager. And for the text search, straight C++ stuff is fine. You know the file. Once you know the file, then you can read it. Okay. One thing that would be nice to do, because this is a component, and the model is lots of people may be using this component simultaneously, when you're manipulating files, you want to be very careful that you check the good status of the files. You probably want to make a retry wrapper, I think would be a good idea, so that if you can't open it, you sleep for a little bit, then you try again, sleep for a finite number of times, okay? Just because somebody else may be reading that file while you're trying to. And there's a model for it. I've got a current file access project in the, I ought to put it in your project one, help, spring 18. It's in the repository somewhere, and I'll put it in the help file. So now, to debug it, let's do debug. I already built it. I think I built it. Didn't I build it? So let's build. Run build task. And I want to make file system. Oh, I didn't talk about that. So let's talk about that. So now what happens is, yeah, this succeeded because if it didn't, you'd see a whole bunch of GCC complaints down here. Okay? Because what happens is you run the tool, your task tool, and then the problem matcher comes along behind, and if it finds anything, it starts writing a whole bunch of stuff in here. So now we should be able to debug it. So let's just Um, Where's my, make this smaller. And now let's run it. So debug, start debugging. Now I told it I want an external terminal. So here's the external terminal running. Okay. And I put a series of breakpoints. If I didn't put any breakpoints in it, it would just run to completion. But I put, I am testing the demonstrate path class, I'm demonstrating the file class, I'm demonstrating each of those classes. And so you'll see some output. I'm just jumping over, I can single step just fine, but if I jump to the next breakpoint, there's all the output from my paths. If I jump to the next breakpoint, there's all the output of the, the directory stuff. And if I jump to the next breakpoint, attest to the file class stuff, that's here, and, went on and on and on and on. Here, for example, I'm reading the first few lines of the file using the file class and stuff like that. Here I'm reading and writing a short little text file. So debuggers works fine, easy to use, no big deal. So I think it'll work fine for your Linux builds. You don't have to use it. If you want to use NetBeans, you're welcome to. If you want to use GCC directly, you're welcome to. I am using the makefiles I handed out. So let's just pull up makefile system. And this is just, all of my targets. So these list my targets. And I didn't list dependencies. There's only one package anyway that I'm building. So, but I could have put these up in flags. I could have had a flags thing and, all that sort of stuff. But anyway, I have to define test underscore file system because I've got a pound if def, if test underscore test file system around the main. So if I don't define it, that main isn't compiled, and the compiler will complain that there's no main. The linker will complain that there's no main. File's fine, but the linker will complain there's no main. And so I'm taking file system.cpp, and now the launcher wants to run a.out, so I just name my output a.out. And you could go and change the launcher, so if you want to have it, some other name, you can, and change the launcher to use whatever name. And there may be some symbolic way of doing that. If there is, I don't know. Dollar, whatever you built, kind of thing. But I doubt that there is. So, but I think building the makefile. So if you have this makefile is really taking the place of a Visual Studio project or Visual Studio solution. So you're just putting all the stuff, all the structure you want, how you want it compiled. And what makefile does is it does a build, not a rebuild. It's probably a way to make it do a rebuild, but if the time date stamp of some component that I depend on is more recent than the one I'm compiling, it won't compile it. But if the time date stamp is older, then it compiles, based on timestamps, it compiles whatever's needed and no more. Which is, exactly what MS Build does. So I think that's almost as productive as Visual Studio environment. Using Make, GCC tools, nice or Clang, either one will work just fine. And so I think you can set it up so you're quite productive on Linux. Now I was playing around my office today. I installed MS Code on my Windows machine. That's where I discovered, their launcher is using PowerShell, and the tasks need PowerShell, and I don't know enough PowerShell to write what I got to write. This summer I might look at it and decide I love it and start using, PowerShell a lot for that. But That's the deal. But it's very, very configurable. You want to change the way it works? They have, let me see if I can figure out how to, I've forgotten. They have, they have go to symbol and file and go to definition. Okay, so, you know, some of those nice tools in Visual Studio, they have here as well. Configure default build test. So, now, there's a way to tell it, and it may be a key code shortcut. There's a table of keyboard shortcuts. So that should be pulling up Firefox and showing us. Oh, yeah, need to connect. So there's a table of keyboard shortcuts. It's mostly editing stuff, but there is a way, and I've forgotten how you do it, and I won't bumble around here, but basically there's a way of setting up two panes. Here's default JSON controlling properties, and then you can pull stuff over into your, basically what happens is there's the equivalent of the VS Code directory with all of the stuff that manages VS Code. And then there's your stuff like launch and test.json, which go in the VS Code folder in your project, in your workspace. And what happens is when you pull it from the default, you can pull it from the default and edit it like the amount of tabs you want for a, you know, the number of spaces you want when you hit a tab key. And you want to replace tabs by by spaces and stuff like that. That's all there in the JSON stuff. And well, really easy to configure to be your way. Okay, so you know, I would recommend so you can use NetBeans or Eclipse or whatever you want to, but you will. I want you to supply project one with a makefile. I discovered a couple of years ago when we were doing this kind of project that I couldn't. I had a different version of NetBeans than some of the students were using, and it wouldn't process their project files. I had to throw away all their project files and rebuild the project because, you know, it wouldn't upgrade them. And, you know, so I asked you to supply a makefile. So all I'm going to do is run your makefile. I probably won't even pull up the VS Code. I'll just, you know, say make, and I'll pull up VS Code to look at it a little bit, but okay. So I want to talk a little bit about System programming on Linux. We've already had a fair amount. So in Project One Help, there's a bunch of stuff for you to take a look at. What I want is so system programming on Windows. Windows is Unicode to its core. COM is Unicode. Windows Unicode. You really don't need to do a whole lot of system programming on Windows for Project One. You'll have to do a little bit on Linux. So I'll be really quick with this. But we'll talk a little more about Linux and shared libraries and stuff like that. So for us, for COM, there's some header files that will be important for us. So Windows.h includes OLE2.h and WinBase.h that COM uses a lot. So typically we'll just pound include Windows.h. You won't need WinSock, and we won't need the MS-HTML. We won't need process.h because we're not going to do a multi-threaded this year for Project One. There's a bunch of types that Windows API uses and COM uses. We need to understand what they are. So I'm not going to talk about the COM types. I'll talk about that a little later on when we talk about COM. But Windows has defined these capital bool handle p void. This is pointer to void. But Windows uses these definitions because they may change the underlying real C++ declaration. So this is an alias that'll always be used, but if they want to change, maybe, when you move from 64 to 128-bit machines, if we ever do, pointer sizes will be different, so, but we'll still use these same, so the contents of these symbolic things will change, but we'll still use them. So LP, long pointer to void, long pointer to string, tchar, a lot of these we'll see in COM when we're working with COM, long pointer to string, double word, and the definitions are all here. H instance, H module. We already saw H module when we loaded the library, okay? And we saw handle when we loaded when I gave you the DLL demo for Windows. Windows messaging, there is a message type, and the message type is accompanied by a W-param and L-param. So the message type is just an integer. It's an integral type that says 99. Okay, whatever that, button, left button down or something, whatever. But these carry the real information, and they're different for every message. How do you figure out what they are? That's a process called message cracking. Is to understand for any given number, what do these two things mean? And the easiest way to do it, there is a WTL library, Windows Template Library, like ATL, Active Template Library for building COM objects. This is for building Windows applications. And I don't use WTL, but the WTL header cracks all of the messages. It gives you the name of the message, the number of the message, what the L-param and what the W-param are, okay? So now it makes it easy for you to do that Windows programming to the API. And there's a bunch of, references to the documentation. I just want to quickly point out Windows API reference. So each of these things are categories. Now, each of them has functions. We haven't even gotten to the functions yet, okay? So there are thousands and thousands and thousands of functions and structures and stuff in the Windows API. And this organization is, it's actually a fairly good organization. They've categorized it. So if you're working with Windows, oh, you can't see that. Why didn't somebody holler? Now you can see it. So, okay, user interface. So there's categories, and in each category, hooks. There's a score of messages, a score of functions and structures, and blah 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 blah. So there's just an enormous amount of stuff. But this is really pretty well organized. So this will you need it for this class? Probably not. Maybe when we do COM, we'll use some of this stuff, and I may point out that this is coming from that, API. But you want to know that it's here and how to get to it. So the Windows API is just enormous. We're going to talk quite a bit about Windows data types when we talk about COM, because COM, because of its objectives to be able to run code from different compilers in the same program. So a program written in Visual Studio should be able to load a program written in GCC and run it, even though, or interoperate with C#, even though the types may be different. With the difference between GCC and Visual Studio, C++, is there's no binary standard for C++. So when they throw an exception, Windows may not be, if GCC threw an exception, Windows might not be able to catch it. So they've done a whole bunch of things. So COM will return error codes, and there's very specific types that are easy to censor on interface. So they are called they're network data, something or other, NDR, network data standard is what it is, that specifies the size for each of these types. That's what COM uses. And you can't pass much, it's hard to pass anything else, as we'll see. I'll talk about that when we get into COM. COM has a very limited communication structure. There's limited amounts of stuff you can set. You can do everything you need to do. Windows was built on COM, and so you definitely can do anything you need to do, but sometimes you gotta work at it a little bit. So in the API, you'll see, it's very common to see a function. Here's read file and read file EX. So what happens is they came out in some time date with read file. And later on they said, oh my gosh, we didn't. And so now they define read file EX, does the same thing, but it has more parameters. Usually the difference between read file and read file EX, or whatever name and name.ex, is security parameters. It was when, you know, everybody started beating on Microsoft and Bill Gates said, we will get serious about security. So the API got X'd. It probably should have been named Read File and Read File Gates. Anyway. So you see a lot of that in the Windows API. So there's file services, Windows system information, DLLs, processes and threads, memory management, inter-process communication. Almost all of this stuff you probably won't need. I've demoed most of what you need. We did the DLL demo, you know, protocol underscore DLL or whatever, DLL underscore protocol or whatever it was, and that is in the Project One Help Spring 18. You know, so you've seen that kind of stuff. You will, you know, I don't think you're going to file management, directories, registry, dynamic link library. You know, this is just a sampling of the functions and structures they use. Talked about this at other times. There's a bunch of different kinds of memory management in the API. COM uses global alloc, global realloc, global lock, global unlock, global free, global handle, and we're going to use them. There's in the Windows API, heap alloc, heap compact, you know, blah, 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 get process heaps. These things, I'm sure, are used by the C++ libraries for the native heap and by .NET for the managed heap. You can ask Windows, you know, give me another heap. I want a heap. Give me a heap. Memory map files are really part of the virtual file management system. So if you want to share memory with another process, you create a memory map file, and this is a kernel object, and kernel objects have a naming convention. If I create a kernel object and name it, another process later on creates a kernel object with the same name. It doesn't create a new one. It gets a reference to that other one. That happens. Kernel objects are system-wide resources. So a mutex, memory map file, whatever, they're all system-wide resources. So this way, two processes can share memory. Then that gets mapped into their virtual address space. You know, there's a create memory map file and a mapping function that maps it into the virtual address space. A lot of this you'll see examples of in the, you know, if you're interested in the code samples. I don't think you're going to have to use too much for Project One. I think you're pretty much good to go. We'll use a little bit with COM, but you'll see lots of examples from me in order to do that. Linux system programming is a little shorter. Tentative guide to Stevens and Rago is a classic text about that thick, okay, on Unix and Linux. And he's actually got a whole series of volumes. He's sort of like Donald Knuth, who has, you know, volume 1, volume 2, volume 3, volume 4, and he's currently working on volume 5, I think. No, she may complete before he dies, who knows? Okay. And this was kind of like that. I think there are 3 volumes. One volume is totally devoted to networking, setting up networks and socket-based communication, TCP, IP, handling and stuff like that on Unix machines, Unix and Linux machines. So, and this is a, you know, a much smaller, really just a little discussion about how Linux system calls works. So the important header files are these I think, basically, I looked through what I had written in my examples and picked out the ones, there's a lot of them, but picked out the ones that I had used. But, you don't really need a reference so much. If you go into the man pages have a bunch of sections, 5 sections, I think. Section 2, if I remember right, is system calls. System 3 are library calls. And very often there's a big duality between the system calls and library calls. The libraries just make it a little easier to make the system call, and so it's pretty much a one-to-one. This library call calls that system call and does the setup that you got to do for it. So, but if you go to the man pages and grep on the man pages, if you were interested in directory manipulation, that's how I wrote this file system for Linux. Grepped in the manual pages for directory. I got, it's really nice. You get little synopsis of what it is, and they tell you what header file you need to include, and and then if you want to get into the details, you can get into the details. So the man pages are really cool. They work really well. And grep is your friend. Grep stands for General Regular Expression Parser. So it's useful even if you don't know regular expressions, but it gets a whole lot more useful if you do know regular expressions. So a lot of these sys, sys/ came from System 5, I think. There's some error protocols. Integer returns, success returns 0, failure returns a small integer, often -1. And COM does this, but it's got code symbols that you use instead. Okay. There's a macro function called succeeded. So COM functions all return an error code called an H result. It's a status call, and you got to check the statuses. And you do that with succeeded HR. The error code, and it'll tell you. You'll get a true or false depending on whether the call succeeded or not. And I listed a bunch of the system calls here simply because it's a little quicker and easier to see the whole thing than if you go to the, here's the man page. So this is a man page, and and you can grep on that and find what you need. Some stuff about system calls, so that's it. Okay, so I am done with the system programming. We'll come back as we talk about COM and look at a few of those things. But what I want to do is go back to our discussion we started. So I was talking about COM and what the parts of COM. So let's take a look at this. This will probably be all we'll have time to do today. But as of Thursday, we're going to start COM proper. And probably next Tuesday, or maybe next Thursday, I will give you a sheet of code thicker than that, okay? And we're going to go through it pretty much line by line. It's painful, but what that is a raw C++ improc COM component. It's a hello world COM component. It has 2 little functions to send a string and get a string back from the component. And it took that much to do it. Now, the reason we're gonna walk through it, you'll see all the parts, really all the mechanisms that COM uses at work. But for your project 1, you don't need to do that. You could. For years, people took that, what I'm going to show you, and they kept changing the functions, little parts of it to do what they wanted, because there's so many details. No one would, get it right. But Microsoft developed the Active Template Library, make it much easier to build COM components, and that's what we'll use. But you need to understand how COM works for that ATL to make sense. Then we'll use the ATL. I'll show you the structure of ATL. We'll use ATL. You'll find it's really quite straightforward here. So this introduction to COM just lays out a roadmap that says, lays out the structure of COM and talks a little bit about why. So what's the problem? If we're building some large system, tight coupling in large systems makes development really difficult. Many of you may remember a little demo I gave of some research work that one of my doctoral students and I did on the Mozilla failed on Mozilla version 1.4.1 or whatever it was. Okay, it's a failed version of Mozilla browser, and we looked at the dependency structure of it. It was a mess. They had a whole bunch of strong components. Strong components are mutually dependent files. So on the dependency graph, a whole bunch of mutual, closed circuits. And one of them that we looked at in detail in the rendering library was a strong component of 65 files. 65 files, all mutually dependent. I could get from any file to any other file in that set by traversing a dependency path. It didn't mean that every file depended on all the other 65, but it meant indirectly. Directly, everyone didn't depend on all the rest. But indirectly, every one of them depended on every other one. So what that means is that you find an error in one, you fix it, you test it, and you got to test all 65, because they all depend on you. You may have broken them, so you got to test them. And in that testing sequence, you say, oh, I did break it. I broke here. So now you got two more problems, and you start testing them, and boom, they each have two. So there's a fission explosion of change problems with very dense dependencies. And so COM is trying to break that. One of the best ways to break it is with interfaces and object factories, because now everybody depends on the interface, they don't depend on the implementation. So, I could make a change to the implementation. Guaranteed I won't break the build. I might break the operation if I change the semantics, but as long as I don't change the interface of, the interface that my factory hands out, or the function calls in the factory, as long as I don't change those, then guaranteed, pull this off to the side, fix it, put it back in, everything runs. You still have to do testing, and if you look at what happens with the dependency graph, you greatly reduce the mutual dependencies by that. Now, instead of two files depending on each other, they both depend on the interface. So to address that, and that was the problem Windows had, so they latched onto COM so that they could build Windows successfully. So first solution is dynamic link libraries, so that we can pull a little part of the code off to the side and work on it. Standard interfaces, so that when I change something, I'm not going to break the people who make calls into me. Registration is a factory process associated with this that this map doesn't call out clearly, but an object factory is another part of that recipe. System management of component lifetime. So in a big system like Windows, for example, the directory management stuff is all COM, or at least for a long time it was all COM. Whether it is still today or not, I don't know. But for a long time it was all COM, and programs all over the place used it. So I might have 17 running programs, they're all using that directory stuff. So a DLL lets me have one piece of code in memory and one piece of code on disk that represents those operations instead of embedding it in 17, which has both a running memory impact and a disk impact. And it's partly complexity and managing the errors and stuff. It's also performance. If I have bigger memory footprints, I do more page faults, things run slower. So, now, if I have lots of people depending on that, so if I got 17 programs that depend on that library, now I have to very carefully manage the lifetime of A, the objects in the library, and B, whether that library is in memory or I unload it from memory. The COM runtime does that, and we will participate in that, that management. Registration in the system registry allows the client to be ignorant of where something is. So I'm writing some client code that's going to use a bunch of components. I don't have to know where they are. I don't have to pull them into my directory. I don't have to make references to some strange path. I just go to the registry, look them up, load it. So that's a good thing. The only problem with that is that Windows shares a registry between the operating system and applications, and that was a really bad idea. Okay. And then it caused for a lot of their instabilities and a lot of their footprints, big attack footprints. And they still have it. I don't know why they didn't partition a long time ago. I don't know why. So if you go join them, okay, ask them why they didn't partition their registry into two parts, one for the OS and one for application. It would have made smaller attack footprint, less problems with getting the system messed up. Inter-process communication is built into COM, and it has to be, because COM wants to support not only code from separate compilers, but they want to support different security models and different threading models. We're going to look at the threading models mostly. So I may have a client that has one threading model and components that have different threading models. And what happens is, if either the security model or the threading model are different, then they communicate by passing messages. They don't get a direct pointer. If they have the same models and they're in the same process, they get a direct pointer from the client to that component to use. But if they have different models, even if they're in the same component, now they have inter-process communication. They have a channel, like we've talked about in SMA and in OOD, that exactly that kind of channel. It might not be a. Some of them are sockets channels. Some of them, I think, are pipe channels, pipe shared memory channels.
Professor?
Yeah.
So how does Solution 4 really help to decouple, loosen the coupling? Get that?
So what happens is, if I don't have an interface, my top level stuff depends on all the lower level stuff that is calling in a very concrete way. If I put an interface there, that top level guy depends on the interface, and the implementing stuff depends on the interface. And as long as I don't change the interface, I can change this guy all I want. I can change this guy all I want, and they can still work together. So so I've changed I had a dependency from the client to this library, and now I have a dependency from the client to that interface, and the library to that interface.
I was asking about the registration thing.
Beg your pardon?
I was asking about the registration.
Oh, the registry?
Yeah, the source 4.
So
Solution
the
4.
registry, all that's doing is allowing a client that doesn't, it allows the client not to have to track where all these components are. Windows in their infrastructure, they have thousands of these components, and one developer doesn't want to have to know where are all those 1,000 components. Today I need those 4, and tomorrow I need those 8. As long as they're installed on your machine, he doesn't have to know. He doesn't have to move them. He doesn't have to copy them. He doesn't have to make references to them. All he has to do is is look up, there's something called a GUID, Globally Unique ID. He uses that GUID, that's a key in the registry, that gets him to the path to the component and loads it. And he doesn't, the client doesn't even do that. The client just says, COM, load this for me. The COM runtime does the lookup and loads it. Automation is the last piece of the recipe. This allows, so not only do we want to interoperate between different versions, different compilers, C++, and different languages like C# and C++, but we also want to be able to interoperate with scripts, as in Python scripts or Ruby scripts or whatever. And in order to do that, there's an automation interface. So C++ and C are compiling against interfaces. A script can't do that. A script isn't compiled. It's translated. Okay, no compilation phase. So how are they going to learn about that interface? And the answer is they aren't. There is a universal automation interface called iDispatch that the scripting languages build in. Okay, instead of compiling to some custom interface, they all compile against a standard automation interface. It's slower. It's harder to use if you're down and doing, all the details. But C# talks to COM objects using the automation interface. They didn't have to. They could compile against the interface, but because of some history, VB used to be a scripted language. Visual Basic used to be a scripted language and had to use the automation interface. And VB was used as a prime way to make it easy for Microsoft developers to use COM. Everybody complained about how hard and clumsy it is to create a C++ client for COM objects, and you're going to find out because you're going to build both a C# and a C++ client. You're going to discover, here's my C++ client, here's my little C# client. Okay, simple. So Visual Basic used the automation interface, and then when Visual Basic became a compiled language, it made this big change of doing exactly the same thing and using the automation interface. And when Anders Hallsberg was creating C#, he wanted to make it interact, he had to make it interact very nicely, very easily with COM, and so he stole more than half of the Visual Basic team. They now became C#, the C# development team, and guess what? They use automation. Okay. It's one reason why when C# talks to the API, to the core stuff, it's slower than C++, significantly slower, using automation. But these are all the parts. We're going to talk about all these parts, over the next 2 weeks. So it looks like I ran out of time. I had a little more I wanted to say. There's more here. Go take a look at some of those slides. I'm going to start talking about COM proper on Thursday, some of the basic ideas, and then on Tuesday we'll look at this one component in great detail. Yes. You got a question about Project One? Project One questions are welcome.
Should we start from Linux platform first?
If I were doing it, I would start on Windows first, and I would just build the C++ core. I wouldn't think about implementing COM. I would just implement the core, and then I would map it into an interface. I would use an interface in Object Factory. Okay. Then I would port that to Linux, and that's an easy port. Yeah. I have what you just looked at today. Okay. And we have the things that will be most useful for you. This file system Windows and file system Linux that you'll use, you don't need to